Welcome everyone. In this video lecture, we will solve a numerical based on the BJT small signal model, and this numerical is just the extension of the earlier numerical that we have made. So the question is to increase the voltage gain of the amplifier analyzed in my previous numerical 3. The collector resistance RC is increased to 7.5 kilo ohm. Initially it was 5 kilo ohm. Okay, but now to increase the voltage gain, we have to increase this one. Why we have to increase, we will discuss. And we have to find the, so we have to find the DC voltage, DC collector voltage, that is our, we have to find VC, okay, DC collector voltage we have to find, okay. In addition to that, we have to find AV, okay, voltage gain, that is our AC voltage gain, AC voltage here. Okay, that thing we have to find, and peak amplitude of the output signal. Okay, so that we have to find. So V naught equals to, we can write it A times of VI. So peak, this one is our peak amplitude of the of the output which we are getting from this collector. So the thing is that this one is our, this transistor is our what, P NP type, PNP transistor is there, and common base configuration is there. So we have to do the calculation for the DC collector voltage first, then voltage gain and peak amplitude voltage. So first of all, this one is a general circuit. We are giving input across this capacitor Vi through this emitter side, and we are getting output across the collector side. Okay. So first we will go for the DC analysis for the calculation of BC. So what we will do? We will do the DC analysis. So what exactly we are doing? First, we are just drawing the same diagram. I have already copied here. So I am just putting here the diagram. Okay. So for the DC analysis, the very first thing for the DC analysis, we have to remove the input voltages. Okay, input voltages. Okay, and the capacitor C1, C2. Okay. So this one is the circuit now. So this voltage is our, simply we can say VE, and this voltage is our VC. So we have to find VC. So how to find VC? So but before that, in my earlier video we have find the all other parameter. So again I am doing the calculation, because this current is our IC and this current is our IE. So first, and beta is given. So beta is given 100. So we can find alpha equals to beta by beta 1, beta plus 1. So it should be 100 by 101. So it will come nearly 0.99. Okay, alpha value. Why we are using? Okay, I will tell. So now we have to apply Kirchhoff's voltage law in this loop, say loop 1, by applying KVL in loop 1. Okay, because finally we have to find IC is nothing but simply alpha times of I. Alpha is known to us. If we know the IE value, we can say IC. So that's why we are just going from this path. So from this path, what we can write, V plus, this V plus voltage minus IE RE, then this one is VEB. Okay, so the this one is grounded, so we can write it minus VEB equals to 0. Okay, means E and B. Okay, so basically we can say like this. This is some kind of resistance, voltage will be there, VEB. So going for negative potential, so write minus VEB. okay, and base potential will be 0. So one can also write minus IE RE. One more line I am going to write minus VE minus V. So base is grounded, VB is grounded, VB is grounded, so this potential will be 0. So I am writing here. We can write V plus minus VE equals to IE RE. So the IE value will be simply V plus minus VE by RE. Now this one will be somehow PN type junction. P, this one is our P junction, N junction, PNP transistor is there. Okay. So this voltage is nothing but simply our 0.7 volt, because this one is our PN. So with this VE is simply our 0.7 volt. It is fundamental. Okay. So V plus will be how much? V plus is given 10 minus 0.7 divided by RE. RE value is 10 kilo, 10 kilo ohm. So this should be 9.3 by 10 milliampere, or we can write it 0.93 milliampere. Simple calculation. So IE is now known to us. Okay. Now IE is known to us. That is our 0.3. So IC value we can find it alpha times of IE. So alpha IE. Okay. So alpha is 0.99 and this will be 0.93 milliampere. So this is somehow 1. So if we solve, it will come around 0.92 milliampere. Okay. So this one is very important, means how we are writing the equation and how we are getting this. So this one is the IC value we have calculated from IC alpha I. That's why we are first finding the IE. Okay, now I is now known to us, IC is also known to us, so we have to find VC. So what we can do, we can directly write KVL through this loop. Okay, means what I am doing, this voltage is say VC, okay, and this one will be RC, and this one is minus 10 volts. So like this kind of circuitry is there. This one is plus 10 volt, we can write like, because now we are writing like this. Okay, so this one is our RC is 7.5. So if we apply KVL in loop 2, this one is same one. Okay, so what we can write, plus VC minus ICRC, because the current in this one will be IC, minus ICRC, then plus 10, simply plus 10 we have to write, because the minus plus, okay, in from 0. So what we can write, the value VC we have to find, so minus 10 plus IC RC. So this will be minus 10 plus IC value we have calculated 0.92 into 10 to the power minus 3. RC is also known to us 7.5 kilo ohm, so 10 to the power 3. So this should be cancelled out. So it should be minus 10 plus, if we multiply 0.92 into 7.5, okay, it will come around 6.9. So the value will be minus 3.1 volt. Okay, so we have calculated the value of DC collector voltage will be this. How much? 3.1 volt, minus 3.1 volt. Okay, so first part is over now. Now we have to go for the AC analysis for the voltage gain. Okay, AC analysis. AC analysis. Okay, so once again we are just making the same diagram here. Okay, now for the AC analysis, what we have to do, we have to remove the DC supply. Okay, just remove it. Okay, then after make it ground here. Okay, make it ground. Okay, and the capacitor will be sorted. Capacitor will be sorted for the AC analysis. So what I am doing, the capacitor will be sorted. Okay. The capacitor will be sorted. Okay, and DC supply will be grounded. So one can also draw the same circuit like that. I'm doing the same circuit because in my earlier video, this one is our base part, it is grounded. This part is our emitter. Okay, touch it. And this one, from this emitter, some resistance is going downward, so it is RE. And from this side, collector side, one resistance is there, that is our RC, and this one is the voltage V naught, output voltage. And from this side we are giving some input, so you can like this, or simply you have to write VI. So this one is the same circuit we have made. Now we have to draw the AC equivalent for this transistor, means this side our collector and base, which is, sorry, base. So what we will do, emitter, base, collector. So we know the how to do the R equivalent. So base emitter junction, so there may be some resistance, that is our simply our RE. Then some current will go up. Okay, this one is our RE, and this one is our, simply I am writing VI, and this would be alpha times of IE RC. This one is grounded, V naught VI. Okay, so basically what this portion, this one is nothing but simply this transistor. This transistor is replaced by this model, where this one is our RE. Okay, this one is our emitter one, emitter. In between emitter and base, some resistance RE, and the current is going like this, IE. So it should be IB, and it should be IC. So it should be IC. Okay, so IB current is going. This would be IE. This current will be IC, and this current will be IB. So we have to find the gain. Okay, very simple thing. The same circuit by using RE model, hybrid we are doing. So now we have to find gain. Okay, so V naught value, the V naught value will be this current into this potential. This V naught will be resistance into this current. So what we can write, alpha times of IE into RC. This current into RC, and VI value, VI, this value is also VI, and this value will be also VI, because this one is grounded. Okay, this having the same potential, zero potential, zero potential. This one we having the voltage VI. So this resistance RE, this one is VI, and it is grounded. Okay, so this current is flowing IE. So VI is simply IE times of RE. Very simple. Okay, so VI, this voltage will be also same. So IE into RE. Okay, so the voltage gain value will be V naught by VI. So it should be alpha IE RC by IE RE. So this IE will be cancelled out. So the numerical value will be like RC. Okay, so alpha value is 0.999. Okay, RC is 7.5 kilo ohm. So 10 to the power 3, and RE we have to find. Okay, RE we have not find, so RE is equals to 25 millivolts by IE. Okay, so we can easily find in last numerical. we have also find means the I value is we have no 0.93 millivolt. Okay, so this milli will be cancelled. So 25 by 0.92 or 93, okay, 92. So it is 27.2 ohm. Okay, so RE will be simply 20. This formula, very standard formula, 27.2. So make it 27.2. I did all the calculation, that's why I can write easily. So the AV value, if we solve this one, it will come around nearly 272 volt by volt or unitless quantity. So this one will be the gain. Okay, so this one is the gain that we have calculated. Okay, now this one is the second part that we have calculated. Now in our question it is given the input voltage, okay, the input voltage is somehow like this. Okay, this one is at 10 millivolt and this one is minus 10 millivolt. Okay, so this one input voltage is given, so v naught by vi is av. Okay, so v naught is av times of vi and input voltage 10 millivolt peak. So v naught will be simply av, that is our 272 into vi. Vi is 10 millivolt. Okay, so it will come nearly 2.7 volt. So we can easily draw the output waveform also, means vi with t is somehow some like temperature, sorry, curve like this. So the output voltage vc will be, this one is vc equals to minus 3.1 volt. DC one we have find out minus 3.1 volt, and this should be our 2.7 volt peak. So this height will be 2.7 volt. So this will be the output response. So this is all about this question, and this question is very similar to the earlier one, but this one is the numerical which is given in the exercise problem. So that's why I solved the same numerical. So okay, so voltage gain increase because AV equals to alpha RC by RE, a small RE. Okay, so now in earlier one it is RC 5 kilo, now 7.5. So automatically the AV will be increased because in the first case, in the last numerical it came 182, now 270. So this is all about this numerical. So follow this numerical and also follow the numerical number 3 for more details. So thank you for watching this video. Thank you.